Hello everyone, I am Dr. Godandaraman. In this section, we are going to discuss with Fourier series introduction. So, he is the Fourier professor. So, for given honor, the very important topics are Fourier series, Fourier transform. So, given honor for this title, Fourier. So, Fourier series, Fourier transform. So, the born 21st March 1768, the place of France, and then death 16th May 1830. So, the field mathematician and physicist and historian. So, here we should discuss with the Fourier series. Periodic phenomena occur frequently in many physical and engineering problems. For example, it occurs in sound wave, flow of heat, electromagnetic wave, mechanical vibration, motion of earth and hot under normal condition. These periodic phenomena are represented by periodic function which may be complicated. So, it is important to express such a general periodic function in terms of simpler periodic function, namely sine and cosine function. A representation in the form of trigonometric series a0 by 2 plus summation n from 1 to infinity a n cos nx plus bn sin nx. So, periodic function is nothing but if equal interval, so the value of each ordinate function of x repeat itself. For example, f of x equal to f of x plus a. For all x value when it changes, so the period equal interval, then y equal to f of x is called periodic function having period a. For example, sin x, cos x are periodic function having a period 2 pi. So when n is in any integer, sin x plus 2n pi equal to sin x for all x, hence sin x is periodic. When I am giving n value 1, sin x plus 2 pi. So sin x plus 2 pi is nothing but sin x for every x. When I am changes x to 2, 3, 4 and so on. So here if a is any positive number smaller than 2 pi, it can be shown that sin of x plus a equal to sin x is not true for all values of x. Therefore, 2 pi is the smallest number p such that sin x plus p equal to sin x for every x. Accordingly, 2 pi is the period of sin x. Similarly, cos x is a periodic function with the period 2 pi. The periodic function we know for all x, just see here, x plus 2 pi equal to sin x, sin of x plus 4 pi equal to sin x, sin of x plus 6 pi equal to sin x and so on. The smallest one is 2 pi. So, 2 pi is the period of sin x. Similarly, cos of x plus 2 pi equal to cos x, cos of x plus 4 pi equal to cos x, cos of x plus 6 pi equal to cos x and so on. 2 pi is the period of cos x. So, this is a form. So, see here minus 3 pi, 2 minus 2 pi, minus pi, 0 pi, 2 pi, 3 pi, 4 pi. Here the period is nothing but 2 pi. So, every interval, equal interval 2 pi. The period is 2 pi. So, Euler's formula is nothing but a function f of x defined c to c plus 2 pi can be expanded as the infinite trigonometry series. So, f of x equal to a0 by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin nx. Here a is the coefficient value. So, to calculate a0, a n, b n, a0 is nothing but 1 by pi integral over c to c plus 2 pi f of x dx and a n 1 by pi integral over c to c plus 2 pi f of x cos nx dx for n greater than or equal to 0 and bn equal to 1 by pi integral over c to c plus 2 pi f of x sin nx dx for n greater than or equal to 1. So, this is a Euler formula. So, when the given the series to calculate the coefficient value of a0, an, bn, so using this formula. This value a0, an, bn as are known as Euler's formula. So, this is a professor. So, Dirichlet condition is very important for finding the Fourier series. So, born is 30th February 1805. So, here also the French mathematician. So, death is 5th May 1859. So, is a German mathematician. The field is a mathematician. So, Dirichlet condition is nothing but the important conditions. F of x periodic, it's single valued and finite. F of x has a finite number of finite discontinuity in any one period and has no infinite discontinuity, f of x has at the most a finite number of maxima and minima. So this is an important condition, Dirichlet condition. So first of all, the Dirichlet condition not necessary but only sufficient for existence of Fourier series. So I just explain here all the three condition in picturized form. See here, now to consider, so this is a function. So this is a, when we compare with the time domain, frequency domain, the time is nothing but so 1 by t, 3 by t, 5 by t. So t is the time, the frequency is moving the period t, 2t, 3t and so on. Here t is the period, t, 2t, 3t, 4t, 5t and so on. So now see here, what is a condition? First condition is what? F of x is the periodic single valued and finite. So single valued is nothing but single, when the function of x, we should give the value x equal to some value. After the integration we have only one answer, is a single value function. Also it's a finite. See here, suppose the other picture to cover, it's a moving, so up to infinity values are moving. So the curve is moving up to infinity. So therefore it's not satisfied the single valued, it's an infinite number, multiple number of value. So the first picture single valued, the second picture is a multiple value. So the first one is satisfying the single value and finite condition, second picture is not satisfied this condition. And then second condition, f of x has finite number of finite discontinuity in any one period and has no infinite discontinuity. Here periodic is here 0 to t, t to 2t, 2t to 3t. So it's moving for here t by 2, 3t by 2 and 5t by 2. Some discontinuity is happen, but it's a finite. When we consider 0 to t is a one period, the particular period, so only one discontinuity is happen. It's a finite number of discontinuity. Therefore the second condition satisfied for this picture. See here, within this number, suppose we consider 1, 1 to here 8, 16 and so on. So within one period 0 to 8, when we consider one period, within the period multiple number of discontinuities happen, infinite number of discontinuity it's a happen. So this second picture is not satisfying this above condition. And then third condition, f of x has at the most a finite number of maxima and minima. So when this condition, we have one maxima, one minima. When we can see here, so this is a one maximum, this is a one minimum within the period of 0 to t. But see here, the frequency, when we consider multiple, the frequency is increasing. So 0 to 1 we have more number of, the most of the comparison. So we have many maximum, many minimum. So infinite number of maxima, infinity number of minima it's happen for the second picture. Therefore it's not satisfying this condition. So the Fourier series is difficult to apply with this condition, the picture of second picture. So the first one is, this is a maximum, this is a minimum. So one maximum, one minimum. So finite number of maximum, minima, yes, it's possible for using to find the Fourier series. The convergence of Fourier series, the convergence is nothing but, let f of x be defined in C to C plus 2 pi and satisfying the Dirichlet condition, then f of x can be expanded as a Fourier series. So this is a series expansion, f of x equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin nx. Let a be any point in the interval C to C plus 2 pi. Then a is either a point of continuity or discontinuity of f of x. A is a point of continuity, then the sum of the Fourier series when x equal to a is f of a. Another condition, if f is an interior point of discontinuity f of x, then the sum of Fourier series when x equal to a is nothing but negative side, positive side divided by 2, taking the average negative side, positive side by 2. When at the end the point of interval x equal to c or x equal to c plus 2 pi, then the sum of the Fourier series is nothing but f of the positive side f of c plus and plus f of c plus 2 pi negative psi by 2. So taking this average. So this is a useful formula for finding the convergence of Fourier series. Thank you.